You need to probably learn a little bit more about binomial expansion. We're going to prove something for calculus in a few days. If all you have are tricks around the math you don't understand, you're not going to be ready to prove the power rule for derivatives. I promise you will eventually. So, without using Pascal's triangle, you have to be able to expand binomials. That's our goal for today. Some things you need to know. 2 factorial, or any number. Factorial is that number multiplied by all of the whole numbers down to 1, or the natural numbers down to 1. You can only do factorials on positive integers, let's say. 3 factorial would be 3 times 2 times 1. 4 factorial would be 4 times 3 times 2 times 1. Hopefully you're getting the idea. 1 factorial is, I think, fairly obviously 1. However, 0 factorial, not so obviously, is also 1. That's just by definition. I'll try to explain what that means in a minute or so. So you need to know how to calculate combinations, meaning you're choosing things where the order doesn't matter. This first thing on the left, 3 over 0, is read as 3 choose 0, and that is 3 factorial over 0 factorial, 3 minus 0 factorial. You don't really have to expand much to realize, hey, that's 3, 0 factorial is 1, and another 3 factorial, hey, this is going to be 1. 3 choosing 1, there's only one way to, 3 choosing 0, there's only one way to do that. What do we mean 3 choosing 0? You're at a store and you are going to buy, I don't know, some number of t-shirts. The store has 3. How many ways can you go home with 0 t-shirts? Just 1. Sort of weird. So what about 3 choosing 1? That would be, you're at a store, the store has 3 t-shirts, you are going to choose 1 to take home. The math would be 3 factorial over 1 factorial, and also over 3 minus 1 factorial. And so there are 3 ways to take home exactly 1 t-shirt. You could take home the first, or the second, or the third. That's fairly obvious. 3 choosing 2, that's not as obvious. Let's see, the store has 3 t-shirts and you're going to choose 2 to take home. Turns out there are 3 ways to do that as well. If you think about it, if the store has 3 t-shirts and you're taking 2, that's almost the same idea here as you're taking 1, it's just you're taking not 1. So again, we get 3 ways to do that. What about 3 choosing 3? You're going to a store, you're going to buy 3 t-shirts, they only have 3 to choose from. There's only one way to do that. You take all 3 of them home. All right, so you have to know how to do that. So generally, A choose B, what would the formula for that be? Hopefully by now you're on board. That's A factorial, or the number on top, the number of things we're choosing from, and over B factorial, the number of things we're taking home or keeping, and then A minus B factorial of that difference. Okay, what does this have to do with binomial expansion? So most people just multiply things out and don't really think about this. So we're going to multiply things out in a little bit of a longer way. And we're going to color code things, and we're also not going to simplify. I want to show you where the binomial expansion formula comes from instead of just, hey, memorize some junk. So if you were going to multiply everything out, you'd probably do the red A times the green A, the red A times the green B, the red B times the green A, and the red B times the green B. So we'd multiply that all out. And then what would you do next? You'd have to multiply, well, each of those blue green ABs times the blue A, and each of those blue-green things on the left times the blue B. So we're going to end up with 8 terms. And you'll notice when we do that, every single term has a red, a green, and a blue letter, meaning each one of these terms has exactly one A or B from the first thing, exactly one A or B from the second thing, and exactly one A or B from the third thing. Well, what does this have to do with binomial expansion? Well, it turns out I was planning ahead here. And, well, we're going to see these 3 choosing 0, 3 choosing 1, 3 choosing 2 things coming back. So, how many ways, let's look through this line, how many ways are there for us to choose 0 B's? Well, it's not that one, it's not that one has a B, I want to choose something with 0 B's. Okay? And so, as it turns out, there are 3, because we basically had 3 places to choose. We had 3 places to choose, and we wanted 0 B's. So we got 3 over 0. We already did that math. There was one way to choose 0 B's. Okay. So how many ways are there to choose exactly 1 B? Well, that AAA doesn't have exactly 1 B. Oh, this one does. This one has exactly 1 B. That's got too many. That's got 1 B. That's got 2 B's. That's got 2 B's. That's got 3 B's. Okay, so there are 3 ways. How do we do that? That's, well, out of the 3 spots, we wanted exactly 1 to be a B. So 3 choosing 1, we already did that, was 3. How many ways are there to choose exactly 2 B's? Well, let's count these out. Not 2, not 2, not 2 B's. Ooh, there's 2 B's. Not 2, exactly 2, exactly 2, not exactly 2. Too many. There are 3 choosing 2 ways to multiply out and get exactly 2 B's from the 3 binomial factors. Okay? So 3 choosing 2, we already did that, we got 3. And the last one, do you know what the last version is? Well, 3 choosing 3. And we know there's only one way to get all B's, and so 3 choosing 3 has to be 1. So I guess earlier I said, sorry, my keyboard working somehow, it keeps disconnecting, so I have to slowly scroll through. Well, 0 factorial has to be defined as 1. Other ways, let's see, 3 choosing 3, there's no way to choose all 3 of something. Or 3 choosing 0, there's no way to choose 0 of something. Well, there is, of course, just 0 factorial being 1 seems a little strange. Get back to where we were. So, the way, I don't know, you look up in a math textbook, if you had a plus b raised to the 3rd power, this is the binomial expansion without Pascal's triangle. And hopefully by the end of this video, you'll see why not using Pascal's triangle is important. But anyways, so you'll notice it's 3 choosing 0. We're used to those. Now, why is it a cubed and b to the 0 power? Well, we were choosing 0 b's. That's the way I was trying to explain everything. And, well, the powers of a and b always have to add up to 3 because in every single case we're multiplying 3 things together. So this 3 plus 0 always has to be 3. We have, well, 3 factors, a's and b's. We have 3 factors, a's and b's. 3 factors, a's and b's. 3 factors, a's and b's. Okay. And so if we think of choosing whatever number of b's or whatever the second thing is, well, this matches up nicely. The other thing we will typically do is make some nice happy formulas. So I guess I'm thinking, well, 0 B's, 1 B, 2 B's, 3 B's, and I guess if there are 3 B's, there are 0 A's multiplied in. 2 B's means 1 A multiplied in. 1 B means 2 A's multiplied in, and 0 B's means 3 A's multiplied in. All right, so let's think through a times b squared. I know this is easy, and hey, I can do this in my head. Our goal isn't to multiply out a plus b squared. Our goal is to figure out this binomial expansion stuff. Okay? And so, I think, yeah. How many ways are there to get 0 b's? Well, obviously just one. How many ways are there to get exactly 2 b's? Just one. How many ways are there to get exactly 1a and 1b? Well, there are 2 ways to do that. Of course, the order doesn't matter. And so we could say there are 2 choosing 0 ways to multiply out a plus b times a plus b and get 0 versions of b, meaning we're going to have a coefficient 1 on the a squared. So I guess we're building piece by piece. And so that'd be a coefficient 1 on a squared, and we know that to be the case. Well, we've multiplied out something plus something squared. I don't know how many times by the time we get to calculus. There are 2 choosing 1 ways, because they're to get 1 version of b. So that would be 2 over 1, and if that's b to the first power, that's got to be a to the first power as well. What's 2 choosing 1? That's 2 factorial over 1 factorial, 2 minus 1. Wow. That was 2 minus 1 factorial, which is going to be 2 times 1 over 1 times 1, or 2ab. And that's what we're used to getting as that middle term, 2ab's. There are 2 choosing 2 ways to multiply and get 2 versions of b, so we'd be thinking 2 choosing 2, b to the second, which means, well, we only have 2 things. There must be 0 a's. 2 choosing 2 would be 2 factorial over 2 factorial, and then 2 minus 2 factorial. Don't forget 0 factorial is 1. So we just get ab squared. We get 1 version of b squared. We don't get a times b squared. And so now, if you really understood what I was saying, we can write out a formula for a plus b to any power. If you're having trouble with this, you may want to write out kind of what we had before. Meaning, maybe you should do a plus b to the first power, maybe you should do a plus b to the second power. Hey, I wrote that out for you. A plus b to the third power. If you still don't have a pattern, a plus b to the fourth power. And so notice we can't use Pascal's triangle to get our coefficients. Now those coefficients do match. Except for, well, what if I have n is equal to 7? Well, that's going to be very different than n equals 10. And I guess what I'm asking you to do, I'm asking you to write something like this. Well, except this is an n power. Okay. Let me get you started. Okay. So how the heck would I get you started? Well, let's think about this. I know my first term is going to have a coefficient of 1 because that's going to be n choosing 0, and that's going to be b to the 0 power, a to the power n, because if I have 4 a plus b's multiplied together, this is going to be a to the 4th power. If I have 10, if I have 10 up here, 10a plus b's, this is going to be to the 10th power, and so on down the line. Okay. We have that unknown, so we'll just leave that formulaically. Plus, I think you can finish the rest on your own.